Heat pump. Let's take a look again at the window air conditioner. The hot side, the condenser, is outside the building so that it may release its heat to the air. The cold side is on the interior. In a heat pump, we simply reverse the flow in the winter when we want heat. By switching the direction of the coolant, the cold side, the evaporator, flips to the outside of the building, and the warm side, the condenser, moves to the inside. The process remains the same. All the equipment remains in the same place. There's no need to flip your unit around the other way. It's only the flow of coolant that is reversed. By moving air over the condenser, which during the winter we find on the interior, recirculated room air may be warmed over the same coils that cool air in the summer. Note that in the wintertime condition, the heating mode, we are asking the coolant to evaporate in cold air. But when the air is very cold, fluid doesn't want to evaporate, and the compressor must work especially hard to create the appropriate pressure to force evaporation. This is why air-to-air heat pumps are often used in places with milder winters, and they often include electric resistance or natural gas heating coils to aid in heating during the coldest nights. Geothermal heat pump. The coolant in the winter heat pump condition doesn't want to evaporate in the cold winter air. It wants to condense when it's cold. It then must be coaxed with lots of pressure created by the compressor, and lots of pressure means using lots of energy. Meanwhile, the Earth just a few feet down is a consistent temperature year-round, consistently mild throughout the year. It's much warmer than the air in the winter and much cooler than the air in the summer. In the mid-Atlantic states, the Earth, when you dig down a few feet, stays at about 55 degrees. So on a 10-degree winter night, the Earth is a mild 55 degrees. And on a 100-degree summer day, still a mild 55 degrees a few feet down underground. Given that the air is cold, and the coolant doesn't want to evaporate in cold, let's try something. If we can surround the outside coil with warmer, ground-heated water instead of the colder outside air, the compressor won't need to work as hard to induce evaporation. This system is commonly called a geothermal heat pump, though it is also, and frankly more accurately, termed a geo-exchange or ground source coupled heat pump. In the summertime condition, the compressor reverses direction and the inside coil cools the recirculated air. Now we are in the opposite predicament, with the same energy-intensive result. The outside coil doesn't want to condense in 100-degree heat. It wants to evaporate. It's hot. So we replace the hot air with the mild 55-degree water, cooled by a water loop moving through the ground. The compressor simply doesn't have to create the level of high pressure required to condense in 100-degree air when the condenser is instead bathed in 55-degree water. In a geothermal system, then, it is said that we are utilizing the Earth rather than the air as a heat sink. Importantly, the water that moves through the ground doesn't mix with the coolant. The two just exchange heat in the coil. As in previous examples, to picture a heat exchanger, you might think of a pipe of coolant snaking through a barrel of water.